So let's try this hypothesis test, which is asking us to conduct a test about a mean for one sample. So the question says, listed below are the lead concentrations measured in different something medicines. So this kind of medicine is a traditional medicinal system commonly used in India. I'm sorry, I don't know how to say this word, and I'm not even going to try to pronounce it. The lead concentrations listed here are from medicines manufactured in the United States. Assume that a simple random sample has been selected. Use a 0.05 significance level to test the claim that the mean lead concentration for all such medicines is less than 14.0. So first we need to figure out what the null and alternative hypotheses are. So they told us in the question that the claim, right, test the claim that the mean lead concentration is less than 14. Okay, so we already know more or less what we're going to be doing here. The mean lead concentration is less than 14 is our claim. So here we're going to choose the mu symbol that represents the mean, and the number here is going to be the 14.0. In both cases, the null and alternative hypothesis should always be basically the same statement. What's going to be different is the symbol that goes in the middle. So starting with the null hypothesis, we have a drop down here. So what you need to remember is that the null hypothesis always has an equal sign in it. Always. So anything for a test like this, the null hypothesis should have an equal sign in it, period. So the alternative hypothesis in this case is going to have a less than symbol, because remember they told us that the claim is that the mean is less than 14. So a less than is going to go here for this particular test. Now we need to identify the test statistic. So notice they gave us some raw data here. So we can use Statcrunch to find these numbers for us, but first we need to open this data in Statcrunch. We can do that by clicking on this little blue box that's right next to the data and selecting Open in Statcrunch. Now that this is open, let's see if we can make this a little bit bigger. Now that this is open, we can go ahead and perform our test. So the hypothesis tests are going to be under the stat key. And for this one, we're going to select t-stats. Why are we selecting t-stats? We select the t-stats anytime we are doing a hypothesis test for a mean, and the standard deviation that we have comes from a sample. In this case, they actually gave us the raw data for the sample. They didn't give us a standard deviation, but we're going to find one, or rather Statcrunch is going to find it for us, but it will be from the sample. It will not be from the whole population. So t-stats is when you're doing a hypothesis test about a mean, and the standard deviation you have is from a sample. In this case, we only had one sample, so we're going to select one sample, and we're going to choose with data because the question actually gave us the original raw data, a list of numbers, the raw data. It didn't give us summarized information like it had already found the mean and standard deviation for us. So all we need to do is tell Statcrunch where the data is. So remember here it was in this first column, which was titled variable 1. So we just select variable 1 right here in this box, and notice that it populated over here on the right hand side. Next, we're going to go down here to this perform section. So we do want to perform a hypothesis test. So we're going to leave this first little box checked. And the mean that we had in our hypothesis, remember, was 14. So we're going to change this to 14 right here. Notice when we changed it here, it also changed here. And we also need to change the symbol in the alternative hypothesis. In our case, we chose a less than symbol, right? Less than was our alternative hypothesis. So we want the same direction here. That's it. So we're going to go ahead and click compute. The test statistic is right here where it says t-stat. This number right here is our test statistic. So I'm going to go ahead and copy that and come over to my MyMathLab and paste it. This said to round to 2 decimal places. So if I start here at the decimal point and go 2 numbers after the decimal point, I'm at that second 4. To know how I round, I look 1 number further to the right and I see a 3. A 3 means we round down, which means we're going to leave that second 4 as just a 4. Next, we need our p-value. So that was also provided in Statcrunch right next to the test statistic, right here where it says p-value. So this number right here is the p-value. I'm going to copy that and paste it into my answer field in my math lab. This wanted us to round to 3 decimal places. So after the decimal point, we go 1, 2, 3 places. We're at that number 1. We look 1 digit further to the right and we see a 4. A 4 means we round down. In other words, we're going to leave that 1 as a 1. So now we need to make a conclusion. So the way we make our conclusion is always going to be by comparing the p-value to the significance level. So here, the p-value was the 0.091 and the significance level was the 0.05. So in this case, the p-value is bigger than the significance level. And the rule we follow is if the p-value is smaller than the significance level, we reject the null hypothesis H0. If the p-value is bigger than the significance level, then we fail to reject the null hypothesis, the H0. So in this case, since the p-value is bigger than the significance level, we are going to fail to reject the null hypothesis. So if we look back up to our null hypothesis said that the mean is equal to 14. The alternative hypothesis said that the mean was less than 14. And remember, that one was our claim. The statement in the H1, that was our claim. But we just decided we were going to fail to reject the null hypothesis. When we fail to reject something, I like to go ahead and circle it. That to me indicates that that is the statement that I am more or less accepting. I don't have any evidence to reject that. Well, that means that I have to then reject the other one, right? I can't accept both. They said different things. And this one right here was the claim. So by failing to reject the null hypothesis, I've basically said, okay, I guess the mean could be equal to 14. But that did not support my claim, which was that the mean was less than 14. So we would say there is not sufficient evidence at the 0.05 significance level to support the claim that the mean lead concentration for these medicines manufactured in the United States is less than 14.